So very good. So look, some of you may have been with us in person at the Career Opportunities in the Decarbonising World Conference on the earlier on the 8th of March at the National Maritime College. Thanks for joining us again today, or thanks to those who are brand new to our events. You're all very welcome. A reminder that if you're not already on the Energy Cork mailing list, do let us know. You can let me know by email, and we can add you to ensure that you get a notice of these events directly. I'm very conscious that lots of people, or many people, get notice of these events through colleagues, through their own connections, or through their organizations, which is great. Please do keep sharing that. But if you want to go directly onto our mailing list, do send me an email. So by the way, you can find the presentations from previous Energy Cork events, briefings and conferences by following the link on the homepage of the Energy Cork website. That's www.energycork.ie. And as I said, we'll be recording today's briefing and adding it to that website. So look, today we're delighted to welcome our speaker representing Geological Survey Ireland, Rory Dempsey. He's kindly agreed to speak on the topic of geothermal in Ireland, a clean, secure and efficient source of renewable heating and cooling. We're pleased to be working with GSI, Geological Survey Ireland, to highlight the important role that geothermal energy can play in Ireland to help make heating and cooling in the built environment more sustainable. So we'll aim, as we normally do, just as I'm talking here now, I'm conscious that there might be people still looking to get in, so I'm going to keep an eye on that. We'll aim to finish on time at 1:45, and hopefully, and I think we should, have time for Q&A before we close. Do let us have your questions via the chat function. So should be on the bottom of your Zoom window there, chat function. Put any questions you might have for Rory in there, and we'll try and get through as many as we can by the end of the session. Look, importantly, Energy Cork hosted events, including this briefing, wouldn't be possible without the ongoing support of Cork County Council and Cork City Council through their respective economic development funds. So thank you to both of those organisations. A couple of housekeeping items. It should already have been done by default. Please keep microphones on mute for the duration of the event. As I mentioned, we'll have our Q&A towards the end of the session. So please use that chat function to ask any questions. You can start populating that chat now, and we'll try and get to them as efficiently as possible at the end. And this event, as I said, is being recorded and will be shared online afterwards. And so, with all that having been said, I'm delighted to introduce Rory Dempsey, our speaker today. Rory is a geothermal consultant with over 20 years experience in the energy sector. In partnership with Geoserve Solutions, he is currently working on behalf of the Geological Survey Ireland to deliver the National Geothermal Database, NGD, to deliver that project. The National Geothermal Database is a multi-year project aimed at encouraging sustainable development of geothermal energy in Ireland. And I know that Rory is going to go into much more detail on that topic. So Rory, over to you, and thank you for speaking to us today.
Thanks, Kieran, and thanks for the invite as well. Really appreciate getting the opportunity to speak to your membership. So yeah, as Kieran mentioned, work on behalf of Geological Survey Ireland. For those of you who aren't familiar with Geological Survey Ireland, it's Ireland's public Earth Science Agency. It's a division of the Department of Environment, Climate and Communications, and really exists to provide free open access to data, maps, information on Ireland's subsurface, and not just in the areas of geothermal and geoenergy, but in groundwater, seabed mapping, natural disasters, karsting, all of those things. So a critical role in the within DEC. Within GSI, the GSI's geothermal program has been active since the late 90s. Joining me here on the call today are Dr. Sarah Blake, who heads up the program, and Tally Hunter-Williams, who's part of the groundwater unit, but has been working on geothermal for a long time in Ireland. And you know, there's been various products from those efforts over the years. The ground source heat pump suitability maps, in particular from 2015, have been a great resource. And as Kieran mentioned, since 2021, when I've been involved, the focus is trying to go to the next step with those things, and I'll be talking about that today. But in addition to that, as part of the geothermal program, you know, GSI funds external research, provides technical support to policymakers, and which is critical at the moment as the geothermal policy is being developed, as well as a lot of focus on outreach and as we'll get to public demonstration projects. So for the talk today, obviously I want to get to what's important at the end, which is specifically about geothermal in Cork. But in order to get to that point, I want to, you know, first of all, provide a bit of a grounding. Geothermal energy isn't something that unfortunately a lot of people are aware of, or they may have some knowledge of it. So I just want to kind of go back to basics and then build it up through kind of the different technologies, the benefits of geothermal, and I really focus on what we're doing from a governmental level to try grow geothermal in Ireland, and some of the results of those efforts in terms of some recent work we've done on geothermal economics. And that then should hopefully set the context for getting to talk about geothermal specifically within Cork. So in terms of geothermal energy definition, relatively straightforward. Geothermal basically is heat energy that's stored beneath the surface of the earth, and that can be used for heating or electricity generation. And so where the heat comes from, essentially, if you think of the center of the earth is the same temperature as the surface of the sun. We always talk about, you know, obviously with solar PV and stuff, how much energy comes from the sun, but actually the center of the earth is another huge resource of renewable energy. And over time, the earth is cooling, and so all that energy, actually, you can see my mouse there, flows out to the surface of the earth. And what we're trying to do is essentially capture it. Now, the thing is with that, you know, there are other factors that influence the heat flow. You can have different types of rocks in there that are actually radiogenic and produce heat, as well as in the very, very near surface, you know, you're capturing the energy from the sun as well. But that heat flow from the center outwards, it's not constant. It varies as a function of the geological setting you're in. One thing is for certain: as you go deeper, it will always get hotter. But how quickly it does so depends on the geology. So, for example, if you're in a plate boundary or somewhere, you know, really volcanic like Iceland, you tend to have a very steep increase in temperature. There's a lot of heat flow coming there because basically you've broken the earth apart, and it's easy for the heat is close to surface there. Other areas, you know, you basically have some of the layers at the top of the earth thinned out from stretching. Think of the African Rift Valley as an example of that. And again, this is an example here from the Rheingraben, which is another area in Germany where some of the crust has been thinned a bit, and you get a bit of a higher heat flow. But a lot of the earth away from these areas is kind of old continental crust, and that's kind of what we have in Ireland. And there you have a much lower heat flow. So if in some of those, you know, areas where you have lots of volcanics, or even just out in the ocean where you're creating new crust, you might have, you know, an average of over 100 and much higher than that. When you're dealing with an area of continental crust like Ireland, you're looking at about 65. So less heat coming up, but still very, very usable heat. And I think that's one of the critical things. Often when people think about geothermal, they think of Iceland, they think of steam, and they think of electricity. But actually, a lot of the world is not like that, but it still uses geothermal energy. And ultimately, what it comes down to for us is finding the right means to capture that heat and transport it to where we want to use it in an economic fashion. And so Typically, what we're dealing with in the likes of Ireland is a temperature gradient, i.e., how fast the temperature increases as you go down in depth. Somewhere between maybe 20 degrees centigrade to 35 degrees centigrade per meter. So basically what that's telling you, if you go down, let's say 2 kilometers, you might expect to see a temperature of about 60 degrees or something that, for example, you'd be able to run a district heating system off. So that's whereas in somewhere like Laradello in northern Italy, at that depth, you would be producing steam at a couple of hundred degrees and producing electricity from it. So really, when you think of geothermal, you got to think of it not just in terms of the geology, but also what is the technology that you're going to use to capture, to harness that geothermal. So there's kind of a few different end members and to describe, because again, it's important. You'll often hear things like, oh, well, geothermal is not suitable in Ireland. Well, what geothermal are you talking about? There's many different types of techniques. And so starting at the left here, the sort of one that people might be most familiar with, these are kind of the shallow systems. And by shallow, I mean, typically you're talking about 0 to about 200 meters. The technical or the legal definition of that is going to be somewhere around 400 or 500 meters. You can have either closed loop or open loop systems there. A closed loop, you basically circulate a working fluid through a U-tube and take the heat from the rock and bring it back to the surface, put it into a ground source heat pump. An open loop, you're essentially taking the heat from an aquifer, a shallow aquifer from the water there, extracting the heat and re-injecting the water in usually. So good example of that is IKEA in Ballymun. They have a 2 megawatt system there, which produces a lot of heat for that building and actually sits under the car park. And that's, as I'll get to, one of the key benefits of geothermal is a lot of the infrastructure is underground. Sort of moving up a little bit in scale from that, you have what are called hydrothermal doublets. This is where you go down maybe to those depths I was talking about, 2 kilometers to get 60, 70 degree water. You produce it directly from an aquifer at depth. This is kind of maybe equivalent to kind of thinking a bit about an oil or gas reservoir. Produce it up to surface, extract the heat, and then have another wellbore to re-inject the cool water back in somewhere else. And then over time, of course, that's going to heat up from the rock. So these are very common in Europe for district heating, Paris Basin, for example, Munich, Copenhagen, lots of different countries. The Netherlands have these type of systems in there. A sort of variation on that is where in certain circumstances, the heat is there. There might be some pathways for fluid in the surface, but you can't get the rate that you need, the volume of fluid out of the ground. It's just not there. The permeability is too tight, and in which case you can use something called an engineered geothermal system, where you create your own pathway to try and link up the wells. An example of this is the United Downs project in the UK, where they're doing that in Granite in Cornwall, down to 5 kilometers to reduce power. In certain situations, this involves hydraulic fracturing, so injecting water under pressure to break the rock apart and to create the pathways, and that's not always the right solution in a lot of different areas. So and an alternative to that is where you go down at depth and use what are called these advanced geothermal systems, or deep borehole heat exchange, where you don't need any external fluid from the rocks. You're basically just taking the heat from the rock, almost like one of these closed loop shallow systems, except done at 2 kilometers, or in some cases, even they're talking about doing 5, 6 kilometers. So there's a pilot going on at the moment in Germany, which is looking at that. So really the focus for us in Ireland at the moment is these two on the left, the sort of shallow closed and open loop systems and the hydrothermal doublet. The other ones we need to understand a bit more about how they would apply. But I think the key thing here is, again, it's like the temperature is there. You know, when you go down in the earth, that it's going to get hotter. And really, when we talk about geothermal exploration, or we're trying to understand geothermal in Ireland, what we're really trying to do is find the most suitable economic technology to deliver the required temperature and the heat load. And I think that's an important factor really here, is that, you know, with certain systems, you know, again, people, you think of energy, often think of oil and gas. You produce it out of the ground and ship it somewhere. Heat doesn't travel well, and so what we're really trying to find with geothermal is what is the end use? What sort of temperature load do you need? What sort of temperature do you need from the ground for whatever be it heating or district food processes, things like that. and then try and match the technology to what the end use is. And that's where some of the geology comes in, is to understand, okay, what is my temperature gradient? You know, if you need 90 degrees heat, well, then that tells me, you know, if I've got an area with higher temperature gradient, it's going to be more optimum. Things like the flow rate, whether you can get the flow rates out of the rock becomes a critical determination in the technology. I can't use a hydrothermal doublet system unless I find permeability in the rock, sort of cracks and crevices at depth in the rock that water can flow through. So then I'm looking at using an alternative technology like a deep closed loop system or a shallow system. And within that decision-making framework as to what the right technology is, other considerations come into that, like environment, and I don't just mean sort of environmental protection, but actually the physical environment you're operating in. How much space do you have? If you need to bring in a big drilling rig, or if you need to drill, you know, 1,000 shallow wells or something like that, you know, does the environment suit that type of technology? And of course, critical in everything always is stakeholders. You know, what works for the community that you're in, what works for the area that you're in terms of, is the technology something that people support, or is it something people have questions about? And all of that leads you basically into the sort of the optimal extraction technology that you're going to use. And it's one of the advantages of geothermal is that it's highly scalar. When you look at those different technologies, they can deliver a range of temperatures and a range of loads, a range of megawatts. So going back to the ones I was talking about there, for example, your shallow geothermal systems here, be they open or closed loop, that can be anywhere from, you know, 10 kilowatts on an individual house up to, like I talked about, 2 megawatts in IKEA, where you've got 158 90-meter wellbores. There's universities in the US that have 3,000 of these things on their campus heating it, because once they're there, once you drill them, they're gone. They're underneath the ground, and you don't have to worry about them. The Paris type system, you know, when I talk about again shallow or deep, you can see here, you know, those shallow systems, you know, usually, you know, 100 to 200 meters deep. These district heating type systems, you're looking at maybe 2 kilometers, where again, you know, you're talking about 240 megawatts of heating capacity from 40 of these well pairs in Paris at the moment that are producing into different district heating networks. So again, much bigger scale than an individual 2 megawatt project. As I'll get to, heating and cooling are primarily going to be the focus in Ireland, but you can generate electricity from geothermal even in these cooler settings. The United Downs project I talked about in Cornwall, this is something like here, where they're going down 5 kilometers, producing about 5 megawatts of electricity, and then actually hooking up that into a cascading system where the hot fluid, once you've generated electricity from it, you hook it up to a district heating system, or something like horticultural growing or other processes like that can benefit from lower temperatures than are required for electricity before circulating it back and putting it back into the ground. And then, as I said, in many cases where you don't have the permeability, you can't get fluid from the rock, there's these other type of systems, like individual wells that you can extract heat from for something like a swim pool, all the way up to what they're doing in Germany, as I mentioned, which is, I think, something like an 8 megawatt system that they're from one installation that they're going to use to try and heat almost an entire community in Greitstraat in Germany. So within Ireland, as I mentioned, really, you know, when you look at decarbonisation in Ireland, one of the big elephants in the room, as I'm sure many of the people on the call will be aware, is heat. We often talk about wind and electricity and you know, how much we're producing on that, but actually heat is over a third of the energy consumed in Ireland, and it's about 25% of the emissions. And it's a very difficult nut to crack. And so that's where we really see geothermal energy as being a strong contribution, is in the heat sector rather than in the electricity sector. And again, that's just a function of a couple of things. A is the type of geology, but B also because we do have other options like wind. But in terms of what makes geothermal energy a very high potential area in terms of heating is just some of its characteristic. It is 100% renewable. It's basically, you think of the earth as almost like a natural nuclear reactor with that heat coming from the center, it's an inexhaustible supply of heat. It's baseload heat. It's reliable. It is not intermittent like solar or wind. It is always there. It's always producing, which as you'll see in a bit, has some very interesting implications for energy systems in Ireland. It's a really small footprint, as I said. All the infrastructure is under the ground, so there's not, or most of it's under the ground, so you don't have that visual impact piece. You don't have that sort of land base required, for example, as you would for the likes of solar. It is clean. There is no combustion involved in it. It's very, very low greenhouse. And as I said, it's versatile. So it's a solution for one-off houses. It's a solution for residential developments. It's a solution for potentially industrial processes. So a lot of different applications for it there. I think one of the most interesting ones is thinking of the benefits of geothermal is that when you look at an energy systems perspective, what we're trying to do in Ireland is was trying to decarbonize heat, decarbonize transport, often through electrification, which means extra grid load. And extra grid load can be a challenge. To add extra capacity is gigawatts of capacity or billions of investment. And so when you look at, for example, comparing a ground source heat pump versus an air source heat pump, the benefits are really down to the COP, this coefficient of performance, which means, COP is basically how many kilowatts of heat do you get out for 1 kilowatt of electricity going in. And so in an air source heat pump, that might be, let's say, 2.5 or something like that. For comparison purposes, it'll probably be 3.5 for a geothermal heat pump. So that 1 point difference, when you scale it up to the level of heating demand in Ireland, is massive. That is it could be up to, as I said, gigawatt scale. That is something that has to be thought about from a national investment perspective. If we're decarbonizing for the long term and decarbonizing our grid for the long term, that efficiency becomes important because it's kind of a penny saved is a penny earned. If we save using some of that electricity and heat by having ground source heat pumps instead of air source heat pumps, it means you don't have to install extra capacity. And there's been studies done in other countries such as the US, Canada, and UK have all looked at that and seen that there's actually material savings there. And it's not just on the amount of electricity used. There's a critical point here. It's to do with the peak load as well. Ground source heat pumps really reduce the peak load requirement. And if anybody was keeping an eye on the smart grid earlier in the week there, when we had a cold snap, you had nearly 7 gigawatts of electrical demand and only about 0.25 gigawatts of wind generation. And so being able to manage that peak load by being more efficient is going to have knock-on benefits to the entire system, both monetary and actually infrastructure. But beyond that as well, it's a local resource. It's from an energy security perspective, it's great because it's beneath your feet. You can control it. And as I said, because of that COP, you'll always produce less CO2 than some of the other options. And so that said, geothermal is a very small part of the Irish energy system at the moment. There's only 209 megawatts of installed capacity, about 18,000 domestic systems, which are usually on that 10 kilowatt scale. Most of the commercial installations are under 250 kilowatts. There are 3 that are a megawatt or more. One includes the Athlone retail complex. There's the IKEA I mentioned. Actually, the UCC Western Gateway building is another one that's about a megawatt. And just recently, DAA have announced that they're going to do a feasibility study on a very large system at Dublin Airport. And of course, I think they may be interested in having a look at Cork Airport there as well. So looking at this, there's a huge benefit to geothermal, but there's basically a technology that has not taken off at scale. And so back in 2020, GSI kind of were at the heart of looking at this and saying, well, what do we need to do to make a difference here? And they wrote a paper on geothermal for district heating, and then the policy people picked up on that. And earlier or last year, a policy statement was released as a step to getting an actual geothermal policy that's going to set targets, going to define supports, things like that. And we see that as being a Ian Devlin is the guy who's, and Murray McCabe in DEC are leading that. That we think will be a bit of a game changer for geothermal, because once you have all of that legal framework there, it usually tends to kickstart stuff that we've seen in other jurisdictions. But the key with that is when you're setting targets and when you're developing supports, it's important that it's done based off data and understanding. And so that's where the National Geothermal Database Project came out of, was to say, let's define the resource, let's understand some of the economics, and then it will help us with policy and things like that. But that alone, data alone, is not going to help, is not going to do everything. Tangibility is really important, where people can see and touch projects. It really helps them understand the technology. And so I'll talk a bit about, we recently secured some EU funding for some demonstrators. So I'll talk about that as well. And creating awareness is huge. And so when we talk about Cork, we'll be talking about a geothermal working group. We have one of those off the ground in Dublin, and we want to basically replicate that model. So yeah, basically, in the next few slides, I'll go through some of these different efforts and where we are with them. So the National Geothermal Database, really you describe it as kind of from maps to metrics. So we're taking all the geological information we have, and the focus is around the Midlands at the moment. It was in Dublin where we had a lot of data, determining is there potential, how much potential, and what's the where, what, and how of heat extraction. And the ultimate goal here is to understand what the economic metrics are, and also how much CO2 could be created. The next step of this is to sort of take those metrics and try to say, well, okay, how's that going to lead to a market? How's that going to lead to uptake? And that's something where, again, interacting with a group like Energy Cork is something that we're really enthusiastic to do, to really see where geothermal could fit in from a market perspective. From a deep geothermal resource workflow, essentially what we've done is, you can see here, this is just for context, Longford and Cashel, Kilkenny and Ballinasloe. So the Midlands of Ireland was where we focused on. What we did was create a 3D model of geology. You can see a slice through it here, that told us about how deep the rocks are, what type of rocks are there, are the temperatures useful. We backed the model up by drilling a well into a kilometre in Tullamore, to give us some calibration for this. And then we use that to generate a heat in place model. How much heat is there that's at a temperature of 30 degrees or more beneath the Midlands? And what we found is those light yellow, green areas are basically areas where you have 90 gigawatt hours per square kilometers or more, which is huge. We just took a quick look at Tullamore, and that's about 100 times the demand of Tullamore. Now, the next question we have to figure out is flow rates, and whether we can extract that using those doublet type things. The other thing we looked at was shallow geothermal resource. So we developed shallow geothermal is different. You don't necessarily just produce unconstrained heat from the ground. You design systems for very specific demand. So we came up with a demand profile of about 1.5 gigawatt hours of heating and 0.5 gigawatt hours of cooling. And try to match them to sort of say, well, what would those be? It could be a large hotel, a healthcare facility, a public office, or a commercial office. One of the things we have to look at in the future is this idea of networking housing developments. And so we defined a shallow geothermal case for that, in order to develop economics and also develop understanding how much resource is there. And I'll show you in a Cork example of how big the resource is. But firstly, just talk about the economics. So again, what I talked about earlier is the COP, the season performance factor, or this comparing a counterfactual case of using an air source heat pump and a chiller for that load of about 1.5 gigawatt hours per year. You can see that had an efficiency of about 3, whereas for an open loop system where you're coming from an aquifer, which is actually quite a common thing in Cork, you had 5.5, and for a closed loop system you had 4. Now that efficiency, it comes at a cost. You pay for efficiency, much like you do in a car or other things. You have to install a geothermal collector, but you should really think of that as an asset. It's something that goes in the ground and it doesn't need to be replaced. Once it's in there, it can be used for heating, cooling for 25, 50 years beyond. Whereas with things like an air source heat pump, you have those external components that need to be replaced more often. And so the life cycle costs of these can end up being somewhat equivalent, even though the capital costs are higher at the start. But on a daily operating basis, because of that high COP, very, very low operating costs, 5-6 cents per kilowatt hour to actually operate them once you put the capital in the ground, and of course a greater CO2 saving. So this is something we're trying to communicate within the public sector through DEC, is to sort of say, look, public sector, there should be funds there, and we're trying to invest for the long term. Investing in a more efficient technology will have knock-on benefits over the long term. The Gemini project, we're expected to having demonstrators, something that just kicked off recently, a 20 million euro project, 4 partners, 4 years, 15 partners. 2 demonstrators that we're looking at, one in Sligo, where we're doing a sports centre, and one a deep drilling project in TUD Grange Gorman, where we're going to go down to 2 kilometres. So the results from those are going to be very interesting. The deep geothermal well is going to cost about 7 million. If something like that was successful and it becomes something that's developed, you're looking at about a 20 million total capital investment, but that could produce anywhere from, have a capacity of anywhere between 3 and 13 megawatts, which would easily cover, let's say, the 10 gigawatt hours per year that they're currently using to heat that campus through a district heating system. And because these deep systems, these open loop systems, have a COP of 25, that's a very, very low grid demand. So you'd be getting 10 gigawatts essentially of heat for probably less than 2 gigawatts of electricity gone in. So finally, just getting to Cork, we actually got contacted by Derry Crowley and Liam Fingleton from Cork County Council, who very progressive in looking ahead at what the options will be for decarbonising County Hall, and they were interested in deep geothermal. And actually, there isn't a huge amount of information on deep geothermal in Cork, and so we met with them, had a look around the area. And what we're going to do, starting hopefully in January, is go and drill a well like this, a slim hole well down to 1 kilometre, to measure the temperature at 1 kilometre, because the shallow temperature measurements don't always tell you about the deep. So if you go down to 1 kilometre, we should be able to measure a more accurate profile of what we might get at 2 kilometres. We'll also get core information that will help us design the likes of those closed loop systems, permeability information, hopefully tell us, are there signs that there might be fluid to move? And of course, hopefully it'll be an opportunity to interact with many of you on the call, and sort of have an opportunity to do a bit of a show and tell. But the shallow geothermal, that's for the deep. The shallow geothermal potential is proven in Cork. The ground source, the GSHP suitability maps, as you can see here, this green area is highly suitable along the right through the centre of Cork City, out the N25 and the N22, and there's many installations already in place. The Glucksman Gallery in UCC, as mentioned, the Western Gateway, the Cork City Council building. So it's a proven technology. The shallow closed loop systems, actually, we recently did a calculation. Aisling Cunningham from GeoServe, who's on the call, and there is 7.2 terawatt hours per year of shallow geothermal energy within the Cork City Authority boundaries. That is 10 times the current heat demand of Cork City. So you have 10 times the amount of shallow geothermal resource than you actually do of heat load at time, which is a great position to be in. There's lots of talk about district heating and waste heat and things like that. The SEI estimated the waste heat available in Ireland is about 11 terawatt hours. So 7 terawatt hours just in Cork for geothermal, and actually there's 4 in Dublin as well. So final slide. In order to grow geothermal in Cork, I think there's a few things we want to think about. One is creating a geothermal working group, the likes of which we have in Dublin, and would basically be a collective of probably mostly public sector agencies like the Cork County Council, Cork City Council, Energy Cork, and many other stakeholders, hopefully UCC and HSE, people like that. And act as basically a hub for disseminating that energy that information we get from those pilots from Gemini, as well as looking for projects, looking for funding opportunities through things like Pathfinder, where we can really emphasize geothermal. Building on that as well, a lot of research. UCC are involved in a project in near Mallow, where there's hot springs, to try and understand those and what the resource there might be. Hopefully there may be an opportunity to expand future phases of the National Geothermal Database to cover the south. Do some modelling on really integrated, how does geothermal match with district heating or solar or things like that? And I think one of the main things would be trying to find it. I think Cork would be a great spot for exemplar projects. When you look at the Docklands regeneration and you look at those maps on shallow geothermal resource, potential there to really do something different in the energy space, the heating space that's been done before in Ireland with looking at that, as well as lots of big public sector energy users in Cork, like the hospital, UCC, where again you follow the lead of people like Trinity who've installed geothermal systems, and yeah, really think about how to do stuff differently. So I think in summary, geothermal is everywhere. It's really about trying to find the optimal way of integrating it. And I think that's the key message I think we're going to see with a lot of renewable energy going forward from this point is it's not about hydrogen versus wind or versus solar versus geothermal. It's about how do we make all of those things work together, and geothermal can have a critical role in that. So I think I'm well over time here, so I'll leave it at that.
Rory, thanks very much. That was excellent, great introduction to the topic. Thank you. What I suppose what struck me was, in many cases the need to match demand to resource, the type of heat you want to the resource that's there, and that, I suppose I wouldn't have realized that geothermal is almost like a cluster of technologies, that there are different solutions for different heating demands. So I think you brought that out very well. There's lots and lots in those slides. So and I know, Rory, that you're happy to answer questions after this event as well and follow up from people who have joined us. I've got questions at my own, but I'm going to go with questions that people have kindly popped into the chat function here. Our colleagues there from AC Architects are asking, how does planning policy respond to geothermal energy?
That's a great question. I think at the moment that there is no there is no provision that it has to be incorporated or that it has to be looked at, and I think there's no incentive for it to be looked at, which is another thing. I mean, one of the things that really strikes me, the field next door to me here is going to be turned into a housing development with probably 100 houses. Every single one of those houses will have an air source heat pump sitting on the outside of it, and probably a green space in the center. So instead of having sort of one centralized ground source heat pump shared loop system with all the technology on the inside of the houses, it seems to me very inefficient. But why would a developer do anything different unless there's anything telling them that they should be? And I think that's something, once we have the geothermal policy, we do want to trying to get some of the planning people as part of the steering committee for Gemini, so we can really get into that and say, well, what should the buildings legislation say, and what's the right way for these projects to go through planning. But excellent question. Yeah.
Thanks, Rory. Helen Marr from HSE Capital and the States asks if you can provide details, and you can do this afterwards in more detail, I'm sure. Hospitals in the EU, are they typically users of geothermal energy? Are there good examples in that space?
Absolutely, yeah. No, the hospitals are a critical user of geothermal. The NHS and UK have many projects undergoing on the way looking at geothermal. In Ireland, the HSE are doing a number of feasibility studies on for geothermal, Cavan Hospital, and a number actually down in Cork as well. It's again, that idea of stable heat. These type of systems work really well when there's a bit of cooling load as well, and often that'll can be the case in hospitals. So yeah, absolutely, it's one of the key focus areas. Anything, especially that's a campus environment, works very, very suitable for geothermal. So.
Very good, very good. I have a couple of questions here, one from AC Architects and one from Michael Dawkins from RPS around drilling, and one is so the cost of deep drilling. Given the cost of deep drilling, can you characterize the ground conditions suitable for shallower horizontal arrays? So I guess which projects are more suitable for a shallow approach,
Yes.
and
Yeah.
which are more suitable for the more
Yeah.
costly deep drilling?
So the horizontal arrays, the kind of slinky loop, those are really tend to be more so for the smaller load stuff, like individual houses. That's where essentially you're almost using the sun's heat in the top layers of the earth. Whereas once the load start to goes up, that's where you go more to the vertical boreholes down to, let's say, 100 to 200 meters. And so really it becomes about the efficiency of the heat pump, in terms of if you need high temperatures like 90 degrees or something like that, and you're trying to go from, let's say, groundwater or something that's 15 degrees, it's harder to get the higher efficiencies, and that's where you're trying to look to go deeper and say, well, even if I'm still using a heat pump, I need to go deeper to get a higher input temperature into the heat pump. But absolutely, that's the characterization approach we're trying to take, is to sort of say this is what resources available at what depth, and so people can come along with their type of demand and understand what the right type of solution is. And again, it depends. If you're in an urban environment and you don't have a huge amount of space to drill a lot of shallow wells, well, then drilling a couple of deeper wells gives you essentially the exchange area that you need to get the heat, because that's what the ground source heat pump stuff is really all about. It's about heat exchange with the earth or with water. And so whether you have 100 200-meter wells, or several 2-kilometer wells, the heat exchange is the same, but the input temperature is what can change and really drive the efficiency. At the end of the day, it's all about that COP.
Great. And Michael from RPS is asking, what would be the lifespan of a deep well? What is
Um,
the risk of reduced flow due to degradation? Um,
Yeah, I mean, again, easily these things if they're designed and managed properly, 25 years plus. What you're concerned about in terms of degradation, cold water breakthrough is really what you're usually trying to manage, especially in these fracture type systems where where you don't want your cool injecting fluid coming back to your warm producer quickly. So you do have to have a good understanding of the reservoir and build good reservoir models to mitigate that in the design, and then in the operating conditions, like anything. And even shallow ground loop systems are the same. You just have to make sure you have the right filtration, the right reservoir management strategy to make sure that things don't clog up.
Thanks, Rory. William Tolton has an interesting one. Have you looked, or has it been looked at internationally, at options using old mines or even existing mines to get a borehole start? So I guess so that your starting point is already
Yeah.
uh, you've got a head start in the drilling.
Yeah. Well, actually, I mean, in a lot of places, they're Holland, for example, they're not even necessarily thinking of the wellbores. They're actually using the old mines themselves. They're basically extracting, the mines fill up with water, and they basically put the heat extraction loops into that, or the boreholes in it. So absolutely, mine water, geothermal is a big area being looked at the UK. The British Geological Survey have an observatory they've built in I think it's Glasgow or Edinburgh, to where they go into the underground shafts and are trying to extract the heat from it. To get in and drill a well deeper, obviously you need to have the capacity, and probably bring a lot of HSE issues and things like that. But obviously in Ireland, when you look at something like Navan, which is already pretty deep, and we know there's a lot of water flow in there from different things, end of life there, that's something that could easily be turned around into, again, making sure you manage all of the environmental and HSE aspects of it, a heat source. That it's definitely done in elsewhere.
Excellent. Rory, thank you very much. I'm looking at the clock. We're just gone a couple of minutes over, so I think what we'll do is we'll draw things to a conclusion. A reminder, look, if people want to get in touch with Rory, they can do through contacting ourselves in Energy Cork, and we can put people in touch. More than happy to do so. Thank you very much to our speaker this afternoon, Rory Dempsey, for his time and insight, and to his colleagues at GSI. We really appreciate their involvement. As ever, thanks to Cork City Council and Cork County Council for their continuing support for the Energy Cork cluster via their economic development funds. And thanks to you, thanks to everyone for tuning in and engaging and asking questions, joining in with the discussion today. If you have any feedback on this event or would like to discuss speaking or ideas around future briefings, don't hesitate to contact me. And a recording of this event will be available at www.energycork.ie shortly. And we'll be back in early 2025 with more briefings, including one focused on renewable energy, grid curtailment and constraints. Watch out for that one. Make sure you're on our mailing list and that you keep an eye on our Twitter and LinkedIn. So with all that having been said, thank you all very, very much indeed. Have a lovely afternoon and we'll see you all again soon. Thank you.